Hello everyone. Today we're going to be talking about function notation and how to evaluate function notation. So in order to begin, please get the notes. If you have a packet from the school, I did not include this one by accident, and take these notes on a separate sheet of paper for now. Whenever you're finished with the notes, upload them to Google Classroom and you'll get points for them. After you're finished, go ahead and start on the exit slip. By now, you should know what to do on the exit slip. If you have any questions, feel free to contact me. And remember that I don't really get notifications whenever you leave a private comment on stuff, so it may take me a little bit to respond to you. So I would prefer if you message me through LiveGrades or texted me or something like that instead. So let's go ahead and get started. So the point of function notation is basically mathematicians are really lazy and we like to shorten things by a little bit. And another reason is that whenever we deal with multiple functions, we're able to denote what function means what by function notation. So equations that represent functions are often written in function notation. That's just kind of what happens. So we can change y equals 4x minus 1 into f of x is equal to 4x minus 1. So in other words, we change the y into f of x. So we read this as f of x equals, and then we say 4x minus 1. So the same thing applies whenever we're talking about the input and output. So we have that f of x is the output of the function, and x is still the input. Okay? So function notation is really useful in finding a value that's in the range. Remember that before we focused on finding the domain and range of functions. But we're trying to find the range value that correlates to a certain domain value. So if we're given a function and we're asked to find a certain value, we would first have f of x is equal to 4x minus 1. We're asked to find f of negative 7. So in other words, we would have f of negative 7. Notice how the x changed to negative 7. So in other words, we're substituting negative 7 in for x. So we're substituting negative 7. And now we just evaluate. So in other words, we simplify and we reduce and we do all the things we need to do to solve it. So we have 4 times negative 7. That's negative 28 minus 1. Negative 28 minus 1 is negative 29. So that would be our answer for this problem. Let's try some examples. So we're asked to evaluate each of the function for the given value. In other words, we're trying to find f of 5 for number 1. We're originally given that f of x is equal to x plus 7. And we're asked to find f of 5. So f of 5 would be equal to 5 plus 7. And 5 plus 7 is 12. So that would be the answer for number 1. Number 2 is for you to do on your own. Now to number 3. We have h of x is equal to 2 over 3x minus 1, and we're asked to find h of 9. So we have h of 9 is equal to 2 over 3 multiplied by, we change the x into 9, minus 1. Now we start solving this. So we change the 9 to a fraction. We multiply straight across, so 2 times 9 is 18. 3 times 1 is 3, minus 1. We can change the 18 divided by 3 into a 6, minus 1. And 6 minus 1 is 5. And that's the answer for number 3. So, number 4 is yours to try on your own. Number 5. We have f of x is equal to negative x squared plus 6x minus 4. We're asked to find f of 5. So, f of 5 would be equal to negative parentheses 5 parentheses square plus 6 times 5 minus 4. We follow order of operations, so the first thing that we do is to evaluate the parentheses. Well, there's nothing to really do inside of the parentheses, so we move on to exponents. For exponents, we have negative 5 squared is 5 times 5, so 25. So we have negative 25 plus, let's go ahead and do this multiplication. 6 times 5 is 30 minus 4. And negative 25 plus 30 is equal to positive 5 minus 4, which is equal to 5 minus 4, which is 1. So our answer for number 5 is 1. Number 6 is for you to do on your own. Number 7 is yours to do on your own as well, and we'll go over number 8. So with number 8, we have g of x is equal to the absolute value of x minus x squared, and we're asked to find g of negative 7. So we have g of negative 7 equals the absolute value of negative 7 minus negative 7 squared. If we evaluate what's inside of the absolute value symbols, we have negative 7 minus negative 7 squared is going to be positive 49. And negative 7 minus 49 is going to be negative 56. And finally, the absolute value of negative 56 is 56. That's our answer for number 8. Let's move on to the next page. Okay, so we have number 9, which is f of x is equal to 4x plus 11. And we're asked to find f of c plus 7. So this time we're adding a different variable. So in order to do that, we have f of c plus 7. We're going to evaluate this by changing the x into c plus 7. So we have 4 times x changed to c plus 7 plus 11. And now we simplify. So we have to distribute the 4. So 4 times c is 4c plus 4 times 7, which is 28, plus 11. And then if we combine like terms, we have 4c plus 28 plus 11 is going to be 39. And that's our answer for number 9. I want you to give number 10 a try on your own. Your final answer should be negative 2k minus 4. If you don't get that, please reach out to me and I can see what's going on. Okay? So, let's talk about questions 11 through 16. So the importance of function notation is to shorten things down a little bit. So if you read number 11, we have f of 4 plus 9. So we're getting our function from this box over here. So we have that f of x is equal to 8 minus 3x. So what we have to do is we have to replace f of 4 with the function. So in other words, f of 4 will change to 8 minus 3 times 4 plus 9. Notice that the x was substituted with 4 but everything else remained the same. And also notice this plus 9 just got dragged down. Okay? So if we evaluate this, we have 8 minus 3 times 4, which is 12, plus 9. 8 minus 12 is going to be negative 4 plus 9. And negative 4 plus 9 equals 5. So that's going to be our answer for number 11. Okay? Number 12. We have negative 2 multiplied by g of negative 5. So we have negative 2 multiplied by g of negative 5. We can replace with the function. So g of x is equal to x squared plus 2x. We're going to change the x's into negative 5's. So we have negative 5 squared plus 2 times negative 5. And this whole thing is being multiplied by negative 2. So this is the problem that we have to solve now. So we have to do what's inside the brackets first. So we have negative 5 squared, which is 25, plus 2 times negative 5, which is going to be negative 10. We have 25 plus negative 10, well, same thing as 25 minus 10. That's going to give us 15. And then finally, we can do the negative 2 multiplied by 15 to give us the answer of negative 30. Okay? So, let's move on to number 13. So with number 13, we're using the same function, but we're adding two different outputs. So we have to use the function twice, so g of 4 plus g of negative 1. So we're going to be using g of x again. So in order to do this, we first have to replace it with 4. So that's coming from here. We have 4 squared plus 2 times 4 plus g of negative 1, so we're going to replace x this time with negative 1, plus negative 1 squared plus 2 times negative 1. Okay? And that's what we need to solve. So using order of operations, let's figure out the parentheses first, which nothing's really needed with the parentheses, so let's move on to exponents. We have 4 squared, which is 16, plus 2 times 4, which is 8, plus negative 1 squared, which is 1, plus 2 times negative 1, which is negative 2. Okay? Now we have 6 plus 8, which is going to be 24, plus 1, plus negative 2. 24 plus 1 is 25. Plus negative 2, and 25 plus negative 2 is the same thing as 25 minus 2, which is 23. That's our answer for number 13. And now we have 14, which is 3 times h of 2 minus f of negative 9. So we have to evaluate this. So we have 3 times h of 2, so we're using h of x. We're going to replace the x with 2. So we have 3 times, bracket, negative 5 over 2 multiplied by 2 minus 1. So this came from the function that's over to the left, and we replaced x with 2. Minus f of negative 9, so we're going to use f of x up here, and replace the x with negative 9. So we have 8 minus 3 times negative 9, and now we're going to solve. So we have to focus on what's inside of the brackets first. So we have 3 times, bracket, negative 5 over 2 multiplied by 2. Well, that's the same thing as or these 2's cancel because one's on top, one's on bottom. We're left with negative 5 minus 1 minus 8 plus 27, because negative 3 multiplied by negative 9 gives us a positive 27. If we simplify this down again, we have 3 times inside the bracket would be negative 5 minus 1, which is negative 6. Minus 8 plus 27 is going to be 35 inside the brackets. And then finally we have 3 times negative 6, which is going to be negative 18 minus 35. And if we simplify this, we get negative 53. And that's going to be our answer for number 14. Number 15. If f of x is equal to negative 13, we're asked to find the value of x. So if f of x, in other words, this guy, so if 8 minus 3x is equal to negative 13, what is x? So in other words, we have to solve this equation for x. In order to do that, we have to subtract 8 from both sides. We're left with negative 3x is equal to negative 13 minus 8 is going to be negative 21. And in order to solve for x, we have to divide by negative 3. And that gives us that x is equal to positive 7. Okay? And now for number 16, we have if h of x is equal to 39, we're asked to find x. H of x, if you look over here, is negative 5 over 2x minus 1 is equal to 39. Now we have to solve this guy, so we're going to add 1 to both sides. We have negative 5 over 2x is equal to 40. And then we have to get rid of this fraction, so we're going to multiply by the reciprocal. Two on top, 2 on bottom, negative 5 on bottom, negative 5 on top. That leaves us with x is equal to 40 times 2, which is 80 over negative 5. And 80 divided by negative 5 is going to be negative 16. And that's our answer for 16. Let's move on to number 17. So with number 17, we have an application problem. With this one, we are being asked to solve this word problem. So we have the anthropologist used the length of certain bones of the human skeleton to estimate the height of a living person. One of these bones is the femur. To estimate the height in centimeters of a female with a femur length of x, the function h of x is equal to 61.41 plus 2.23 multiplied by x can be used. Find h of 46 and explain its meaning. So we have to find h of 46, so we're going to use the function h of x. Replace x with 46. And start solving. So we have 61.41 plus 2.32 multiplied by 46. If we do that multiplication, we have 106.72. And then if we add these two numbers together, we have 168.13. So we're asked to determine what this information actually gives us. So we have that x was replaced with 46 and that the femur length would represent x. So we can say that a female with a femur length of 46 centimeters would be 168.13 centimeters tall, because this function is what determines the height given the length of the femur. So a female with a femur length of 46 centimeters would be 168.13 centimeters tall. Okay? Let's take a look at number 18. So, with number 18, with the graph of f of x, we're asked to find each function value. So in other words, we have to look at the x value that's given, find it on the x-axis, and figure out what value would be associated with the graph. So we have for a, it's f of negative 3. So in order to do this, we start from the origin, we go to negative 3, and then we go to wherever the graph would be. So in this case, it touches right here, and we figure out what the y is, and for this one, the y is 2. Moving on to letter B, we have f of 1. So that means x would be 1 in this case. So we go to 1, then we go up to the graph, wherever it touches first, and we go over to the y. That gives us a y of 2. And let's move on to C. We have f of 0. So we go to x equals 0, which is right here. We go up to touch the graph. The graph touches at 1, 2, 3, 4, 5. So our y value would be 5. And finally, letter D, we have f of 2. So we go to x equals 2, which is 1, 2, right here. And this time we have to go down to the graph till it touches. And it looks like it touches right there, so that would be negative 1, 2, 3. So that's what we have to do with number 19 as well. Looking at this, we have the function f of x. We're asked to find f of negative 4. So we go to negative 4. 1, 2, 3, 4. We go up to the graph. It hits here. We look over to the y. That looks like it's at 2. Letter B, we have f of 0. It's right here. We don't really have to go anywhere, so that means that the y would also be 0. C is f of 2, so we go over to 2. This time we have to go down, touches the graph here. We go over to the y-axis, and that's negative 2. And finally, we have D, which is f of 5, so we go over 5. 1, 2, 3, 4, 5. And we have to go down to the graph. It touches here, and that's over at negative 1. So I hope that this helps you understand a little bit more. If you're still a little bit confused with this, please reach out to me on Wednesday. I do have office hours. Once you're finished with this homework and the problems I asked you to complete, which I believe are 2, 4, 6, and 7, please upload this document to Google Classroom so I can grade it. And again, if you have any questions, please don't hesitate to contact me. Hello everyone. Today the audio might be a little bit different because I'm trying a new way to record my audio. So let's go ahead and get started with this. Go ahead and get the notes out, and we'll go from there. So today we're going to be talking about zeros of functions. So in other words, it's the, well, you might be asking the question, well, what are zeros? Graphically, zeros are the points at which the graph crosses or intersects the x-axis. And algebraically, it's when the points, or the points at which f of x is equal to 0. Okay. The zeros also have different names, so they could also be called the roots of a function, the x-intercepts, and also the solutions of a function. Okay, let's go over a few examples with this. So with these, we're given a graph and we're asked to find the zeros of each function. So what we have to focus on is to find where the function crosses the x-axis. So with number 1, we have this function. We have one point at which it crosses the x-axis, and it would be right here. So we have to determine what the ordered pair for this would be. So the ordered pair, remember, is of the form x comma y. So in order to go from the origin to the point, we go right 2, so x would be positive 2, and we don't have to go up or down any, so it will be 0. So 2 comma 0 is going to be our 0 for number 1. Number 2, we have 2 points at which the graph crosses the x-axis. We have one here and one here. What we have to do is find the x value that's associated with it. So we have 2 possible values. We have it crosses at x equals, looks like -2 and +1. So those are the zeros of this function. If we go back to number 1 real quick, instead of writing the ordered pair, we can also write x is equal to 2 as our 0. Okay? Let's go to number 3. Number 3, this graph does look a little bit weird, but we're looking for the point at which it crosses the x-axis. That point would be right here. So when x is equal to, looks like 1, 2, 3, y is 0. So in other words, f of x is 0. I want you to try number 4, number 5, and number 6 by yourself. With number 6, make sure that you look and see that there are 3 different points that cross the x-axis, and be sure to include all of those. Let's go to the second page. So we talked about solving graphically, but what happens if we have to do it algebraically instead? So there's 2 steps for it. The first step is to set the function to 0. So set the function equal to 0. And step 2 is to solve for x. So let's give it a try. Number 1, we have, number 7, we have f of x is equal to 4x minus 8. So what we have to do is we take the function 4x minus 8. We set it equal to 0. That's our first step. Our second step is to solve for x. So in order to do that, we have to add 8 to both sides. We have 4x is equal to 8. Divide by 4 on both sides now. And we're left with x is equal to 8 divided by 4, which is 2. And that's our answer. Try number 8 by yourself. Let's move on to number 9. So we have f of x is equal to negative x plus 7. We have to do the first step, so we're going to take the function negative x plus 7, set it equal to 0, and start solving. So with this one, we're going to subtract 7 from both sides. We have negative x is equal to negative 7. We have to divide by negative 1. And we have x is equal to positive 7 as our 0. That's our answer for number 9. Number 10, I want you to try by yourself. Let's take a look at number 11. We have f of x is equal to 1/2 x plus 2. So we take the function 1/2 x plus 2. We set it equal to 0. Now we have to start solving for x. So we subtract 2 on both sides. We have 1 over 2x is equal to negative 2. We have to get rid of this fraction, so we're going to multiply by the reciprocal. So 2 over 1 multiplied by 1 over 2. We're going to multiply the other side by 2 over 1. 2's cancel, 1's cancel. We're left with x is equal to negative 2 multiplied by 2 divided by 1. That's the same thing as negative 2 times 2, which is negative 4. And that's our answer for number 11. I want you to try number 12 by yourself. Normally, we would do 13 through 22, but since you all don't have access to a graphing calculator, I am going to skip these for now. And that concludes the video. So remember that you're in charge of 12, 10, 8, 6, 5, 4, and that's it. So if you have any questions whenever you start working on this, please let me know. After you submit the notes, please be sure to start on the exit slip. I hope you have a good weekend.